We are started. Yay!
Okay.
It's gonna be one of those weeks, boys.
Yeah, with the new president.
Oh yeah. Have you guys been keeping up on the numbers?
All my roommates.
I have what's it called? Like the live election results, but it's like I think Trump's winning. Or
Yeah.
not 188. 188 Clinton, 187 Trump.
Wait, what?
Clinton has 188, but Trump has 187.
Oh, that must be old.
Yeah.
Because the numbers I have right now are 197 Clinton, 216 Trump.
Oh, snap.
Okay.
Are you watching on
So-
Fox?
No,
Team
I just
discussion.
Oh, okay. Yeah. Oh,
Okay.
math.
Team
You guys-
discussion.
Donald Trump
Okay.
could be our
Let's
president.
go.
That's hilarious. I know.
Or Hillary Clinton could be our president. Oh, we're so screwed either way, guys.
It's gonna be Trump. But the hangout on it says, begin by discussing what a vector is, how to find the component form given the magnitude and direction and vice versa, and how to do the vector operation of addition, subtraction, and column multiplication that produce an angle between two vectors. Okay.
All
So
right.
what is a vector? It's
A
a
vector.
like a way. It's a tool to measure, but it has direction and magnitude, not like the polar or scalar form that is just
Like Despicable Me.
thing. What do you mean?
The villain in Despicable Me, his name is Vector, and he goes, committing crimes with both direction and magnitude. Oh yeah.
Well, I don't remember that. Maybe in Spanish it's different. I don't know.
It probably is.
Okay,
Or
but
you
cool.
just never knew what a vector was.
Oh, that's true. I didn't know. I remember like my teacher in high school talked to me about it because but well, I thought that it was really complicated because that's what he said. Like it's hard, it's kind of hard.
Yeah.
But I don't think that it is like that crazy. I don't know.
Oh my
Okay.
god, dude.
Vladdy, what are you watching?
I gotta get that on video, man.
My friend sent me something. So
Oh my god.
there's so many memes.
Okay, so do we know how to do the addition and subtraction? That is pretty similar to you just adding like 2 points, x and y and stuff. It's kind of similar. Right?
Mm-hmm.
Okay. Yeah, I have no question about that.
Me either.
Scalar multiplication, that is the simple one, the one that we have done before, I think. What is the dot product? I didn't see that. I don't know if you guys have seen what is the dot product. Oh, wait. I think that I did. Isn't it the dot product like the vector that you get from 2 vectors?
Well, the dot product is an algebraic operation that takes 2 equal length sequences of numbers and a single number. So yeah, it would be like you add 2 vectors together and that's what you get.
Yeah. Okay, yeah. That's what I thought it was. Okay, because at the end, like, you just get like one, you don't get a vector, you get like again, yeah, one value, right?
Mm-hmm.
That was in the homework. Yeah, well, good. And the angle between two vectors, well, is, I don't know, it's similar to just with the angle stuff. Okay. Any question about point one?
No,
Wadi? Good.
that textbook helps.
Oh, yeah, I have to make it. Okay, point two. Someone else want to read it?
Discuss what a polar coordinate is and how to plot the polar coordinate. Discuss your solutions for converting between Cartesian and polar and vice versa.
Okay. I don't know if you guys saw the video on Khan Academy. They were explaining that in the research stuff, like they called using the tangent, inverse tangent of y and x, y over x, so we can get the angle. And using like the Pythagorean theorem, we can get the r. Did you guys see that?
Yes.
That is right, between converting between polar coordinate and Cartesian, because polar is the one that we have done so far with sine and cosine and tangent. Last week everything was polar coordinates, right? X and y.
Yep.
I don't even care. I voted for neither of them. Guess what?
What?
I went 30 and 10.
That's cute.
I'm so pleased. Like, I messed with one of your classes.
Yeah.
Bloody. Okay.
Hey, dude, we are in a class. We're gonna be done by 10.
It's okay. Let's just keep going.
Okay.
Sweet. I kicked them
Okay.
out.
The number 3 in the preparation assignment.
Ensure that each
Question
team
6.
member was able to develop formulas for converting found in question number 6 of the preparation.
Oh, okay. Well, this is what the video was about. Like explaining about using the tangent and Pythagorean theorem to get from polar to Cartesian and Cartesian to polar. So I have no question about that. I don't know if you guys have.
No, it's pretty simple.
Yeah. We just need to use the tangent, inverse tangent of the like x and y. If we have polar, or using Pythagorean theorem. Okay, please email Natalie or TA to let her know the time so she can try to attend if possible.
I don't know.
She has never been here. We always
Oh.
email her and she has. Huh?
I will invite her to it right now.
Okay, go for it.
I'm scared.
Okay, you guys start working on the things, and I'll invite her right now.
Yeah, invite her. At least we get to know her.
Whatever.
Given two vectors, how would you find the resultant vector? Draw two vectors and the resultant vector. Okay. We do this pretty much with polar coordinates. We need to set like A1 plus B1, comma B1 plus A2 plus B2. And we replace those with A for vector 1 and B2 for vector 2. I don't know if that makes sense, but that's how it is. How can you show you? I can share my screen here, right?
What?
I'm sharing my screen. Cool. Can you guys see everything?
Bullets, bird, sag.
I had to like explain someone about it. So, okay, well, never mind. Other question about finding the resultant vector from two vectors or not?
So if you draw one vector and then you draw another vector, isn't it both vectors added together in between?
I can show you real quick. We have A1, comma, B1, and we have oh, wait. A1, A2, comma, B2, right? And then we just said like this. A1 plus B1, comma, A2 plus B2. Does that make sense?
Yeah.
Yeah.
And this is our vector resultant because it's just, that's how we are supposed to, that was terrible. Okay, cool. That's how you get the resultant vector from two vectors. Cool. Okay, here I tried to read it, but I don't know if I understood too well because it's too long.
Imagínate.
Huh?
No, I'm just kidding. I was about to translate in Spanish.
Imagina el siguiente escenario volviendo. Okay.
Oh.
Okay. When the prophet Joseph Smith was a young man, his father bought a farm near Palmyra, New York. As with many farms during that time, the family spent many days clearing the land to make it suitable for farming. This would have included cutting down trees and then pulling the stumps out of the ground. Sometimes this was done by hooking two chains around the stumps and having two horses going in different directions. Oh, okay, yeah, I remember this. Pull the stump out. Imagine that the two horses have an angle of 65 degrees between them. One horse is pulling at a force of 2,000 pounds, and the other is pulling at a force of 300 pounds.
Yeah, good for
The force will be the magnitude of a vector. What is the magnitude of the resultant force? What is the angle between each horse and the resultant force? Begin by drawing a picture. Remember that a parallelogram has 360 degrees and the opposite angles are congruent. Okay. Does that make sense? I don't know. I thought I saw something like that in the book. It's kind of common that. Okay, found it. In the book that Vladi gave me, there is one in chapter 9. But here they're using tracks. Okay. First, we need to find the dot product of the two vectors. but we don't have, right? We just have forces, an angle. We have 200 pounds, 300 pounds, and an angle of 65.
Hey, one of the bishop
Okay,
rings.
we need to.
I'll be right
Huh?
back. I'll be right back.
So, Bishop X calling.
I think that we need to use the formula.
Vectors, right?
The formula, because remember that we got the magnitude before, and we have to replace the magnitude hit for the force, 200 and 300 pounds. Yeah, that is replacing the magnitude. I see an example here, but it's different. I don't know how to. Maybe I could look at it. What do you think about it?
I'm just trying to picture it in my mind before I start drawing it.
Oh, the drum? But we just have two horses going in different directions and pulling that thing.
Like
Not
an angle.
kind of different thing, but with an angle of 65. Yeah, I guess we could look at the book.
Oh, it was so quiet. I expected you guys to be gone.
I'm gonna look in the book if I can find something like that.
Huge. Huge.
Guys,
What?
we might we might have Donald Trump as a president.
I know. It
It
looks
will
like
happen.
It literally looks like he might win.
it's embarrassing.
Okay, we have it here. It's in page 510. Hey, it's the same one.
Literally?
Pretty much, it said 200 pounds, 300 pounds the other horse. It has the picture and it's an angle of 65 degrees. Page 510, 510 of the book. The two forces are represented by vectors A and B. If A and B had the same direction, then there would be a total for the 500 pound acting on the stump. However, a total for the 500 pound is not achieved because of the angle between the forces. It can be shown by experimentation that one force acting along the diagonal of the parallelogram seen in figure 7.24 with a magnitude equal to the length of the year. Yeah, it has the example and it's explaining it. Do you guys have seen it?
Send the text.
Uh-huh. What is the question? Okay, so it says, what is the magnitude of the resultant force? What is the angle between each force and the resultant force? Okay, so I would say that what is the magnitude? Okay, the vector tray has twice the magnitude of A and minus 2/3 8 has 2/3 of the magnitude for minus 1 minus 8. Some example of scalar multiplication are shown in 723.
Guys, I have to show you this. I'm trying to load the text. Oh man, it just stopped. Dang it. I was like
So-
trying to load the text and it was like crashing on me hardcore.
Man, why don't you tell me to share my screen?
Hmm?
There you go. Do you guys see that?
Oh hey, look at that.
Why?
Nice, nice. Not bad. Not bad.
What happened?
Yeah.
How do you, Zach, can you see your book or you want me to show you the book on mine?
Show me your book.
Okay, there. Okay, here it is. You see what we have? Here we have A and B.
So okay. So if you have that, like still have it up from last time we met. All right. So if you have a parallelogram like that, and this was 300, right? And this was 200, and this is 65, right? And then this is that's the two vectors.
Yes. Well, it's kind of, yeah. Remember, in the two corners,
Well, yeah, that just
right.
65. This has to be then 115, and this is 115.
Oh, okay. You are doing it from the other direction, right? Where is this stamp?
Huh?
Where is the stamp? And what are like? Where are the horses?
This is the stump, and you have a horse here.
Oh, okay. That's A, and the other one is B.
A horse here.
Okay.
This one's a Clydesdale. It has free feet. That's why it pulls harder.
Okay. Yeah, that's right. And we have a total angle of 65. And what we need to try to get is the magnitude. Wait, what is this?
So wait, what are you trying to get?
Hmm?
You're trying to get the magnitude of the
We need to get the magnitude of the two vectors because we have the first, and the first are the. Hey, wait, let me get the book again. We need to replace the magnitude for the force. I think that's what we have.
for the what?
The force, the like the 200 and 300 pounds that there. If,
We have
if,
to,
if
we have to replace that with what?
huh?
We have to replace that with what?
The magnitude of each one is the force that each horse is pulling. So one is pulling 200 and the other one is pulling 300. That is the magnitude of each vector.
Yeah. Okay.
I think that that's something that I saw.
I'm confused.
Oh, look at here. I don't know, but I found another one. Moving a donkey. Anyway, I don't know what page was it that I told you guys. Okay, here. Here, because it said, okay, the vector 2a has twice the magnitude of a. Well, then it says, suppose two drag horses are pulling on a tree stump with forces of 200 pounds and 300 pounds as shown in figure, with an angle of 60 between horses. And now it says, the two forces are represented by vector A and B. If A and B had the same direction, then there will be a total force of 300 pounds acting on the stump. However, a total force of 500 pounds is not achieved because of the angle between the forces. It can be shown by experimentation that one force acting along the diagonal of the parallelogram seen in figure 7.24 with a magnitude equal to the length of the diagonal has the same effect on the stump as the two forces, A and B. In physics, this result is known as the parallelogram law. The single force A plus B acting along the diagonal is called the sum or resultant of A and B. The parallelogram law motivates our definition of vector addition. I think that the key for us to find it is here. Did you see that?
What? That you just gave me a screen share?
Huh?
You might as well take off the Google Hangout. Just use your screen. Because doing a split screen doesn't help anything.
Okay.
My book, it's working again. What chapter is this in?
Chapter 7.3.
The vectors. Literally, this is the first time it's worked in a long time.
Cool, at least it works.
It is good.
It's kind of hard to understand. Yeah, I don't know. We should invite Natalie for Thursday. Hey Natalie, Thursday next week. I mean this week.
Yeah, can you be on our hangout?
Mm-hmm.
Same
would-
direct.
Hmm?
Oh, I'm just reading the textbook.
Okay. Bloody, do you have anything? Or what do you think?
Don't we have to do like the square root of a squared plus b squared to find the magnitude?
I don't think that works in this situation because we're not dealing with.
It's just that we don't have A or B. We just have the magnitude. The magnitude, I think, that are like the force, 200 and 300.
The problem is that you don't have. Like if you were to just do it straight off the trigonometry, you're right, Vladi, because you split the triangle down the line 200, and because it's a parallelogram, you know that the opposite side from 300 is also 300. It applies the same to like a rectangle, so the sides are equal, and because we know all the angles except for the inner angles of the inside of the triangle, then
Hey, here it is. In the assignment said the force will be the magnitude of a vector. What is the magnitude of the resultant first?
So that's what I was thinking. I was like, is it the square root of 200 squared plus 300 squared? But I guess not.
But that's 360. If you look in the key,
Yeah.
it says 425 or something like that.
We need to use that formula but inverted or something like that. If
It
there
has
is
something. It has something to do with the angles. The two individual angles, like these angles, because you have alpha over here and beta over here.
Because for it to be
Hey,
parallelogram, it has to have 65 degrees. We have that one, and there's got to be two of those, and the other one that would fit would be 115.
Yeah, but it's not 32.5 equally split between alpha and beta.
we need to find the terminal component, and we use that doing the sine and the cosine of the angle. The cosine of the angle will give us the A. Got it. I found it. It's here. It's
Eureka!
Huh?
Wunderbar!
It's exercise 13 in the homework. Can you see that? Because here it says, find the component for the vector b with the given magnitude and direction. The magnitude here is 37. Okay, so let me see. It would be for the 200, the point for the vector of 200, it will be 200 cosine of the angle. Okay, wait. Here's, what do you guys think? Should we just put like 6 of the angle 65? Hello.
So if you know side angle side,
Or should we divide that angle of 65 in 2? Answer
well, but
32.
you can't divide it in 2 though, because it's not equal.
It's not congruent.
Alpha and beta are not equal.
Okay, I will use 65 and see what we have, because we have the key, right? Okay, 200 cosine of 65 would give us A, and 200 sine of 65 will give us B. And the other one, the other vector should be 300 cosine of 65 will give us the other A1, and 300 sine of 65 will give us B1. And that's how we can get A and B.
Well, plug it in. What do we get?
Plug it in.
Okay. For A, we have 85, 84.5237 for the first one.
That doesn't make any sense
Why?
because it has to be smaller than 65.
But that is just A.
Alpha or the side? Because you already know the side lengths.
Huh?
What are you trying to find?
We don't have
What are
the
you
side
trying-
length.
Yeah, we do.
What? Which one?
We have the magnitude.
But the magnitude is not the side, right? Yeah, it's not.
What are you finding? Alpha or A?
I am finding A and B.
Alpha and beta or
I mean,
A and B?
I am finding the coordinate, the vectors. That's what I'm trying to find, the vector. The two vectors. If we have the two vectors, we can get the magnitude from both of them, having the two vectors.
Okay.
Because we have the magnitude of the two vectors individually, but we don't have the vector, so how can we get the how's it called? The given, the dot thing? I don't know if that makes sense. Well, what do you, I don't know. I don't know if what I'm doing is wrong then.
So, do we need to find what alpha and beta are before we can find the magnitude?
if we get alpha and beta, we can get the middle, the r, because we will find the common vector, and that will be r, right? I think that if we have the two vectors, because we don't have the vector, we just have the magnitude of both of them.
Yeah, so right now we have a scalar because we know what the
Let me see if I get somewhere doing what I'm trying to do. And if not, like, yeah, I don't know what I will.
Crepes runner.
Okay,
I have no clue, guys.
yeah, this is weird.
To be honest, I have a midterm in my freedom and civil society class, so math got my least amount of attention in between yesterday and today.
252. Yeah, likewise for me too.
No, I got 499, not 425. Where am I missing? Well, I guess it would be better to get a tutoring, I think.
Yep. This week might be a tutor week, boys.
Mm-hmm.
I'll email Miss whatever her name is, Natalie.
Well, but we have done what we can. I mean,
Yeah, we've been on for almost an hour too.
yeah, we have been here for an hour, so.
I'm gonna email both of you guys with Natalie right now and see if there's a way that we can coerce her into being a part of our group this next week.
Okay. Yeah, well, I think that hopefully maybe there is like a homework in the section 2 about this. Maybe that will help us. Because
Yeah.
in the section 1 there is something similar, but I tried to do it and I don't know, I got a close, but it didn't get what it was expected. Yeah.
What time do we want to do our Google Hangout on Thursday?
Huh?
What time on Thursday?
Any time works for me. Do we have a quiz or something? We don't, right? We just need to study for the test.
No, I think we have a group quiz.
Oh, we do?
Yeah, I'm pretty sure.
Okay. Well,
maybe-
if it is like...
Never mind.
Oh,
Should we
yeah.
reconvene? Should we reconvene tomorrow?
Huh?
And should
You froze?
What? Can't hear you right. Yeah, we have a group quiz. Okay. But it's this Saturday the test, so that's good. I'm glad. Before when it was just couldn't check. Hey Zach, where are you?
I think his internet crashed.
Right on time, huh?
Oh no, my internet's losing connection.
Oh no, mine too.
Oh no. Oh
Okay.
no.
Well,
Well, see ya.
we can just text him. Let's just text him because he's gone.
Okay.
Okay, have a good one. Bye.
Left. Bye bye.